So it will cause electronic transitions. So IR transitions, infrared radiations, they are causing vibration of the molecule. So that we call it as a vibrational transition, the energy. And the far infrared radiation and microwave radiations, so they are causing rotation. So we will find these different electromagnetic spectrum, they are causing different changes in the molecule when they are exposing to these radiations. So here out of this you will find, see the contribution relative values, the total energy which is available with the molecule after absorption of the light. So it will have the 10,000 was to 110. So you'll find, so lot of energy is being utilized for the electronic transformations. So that is why you will find here IR and microwave, they are causing rotation, while IR spectrum is causing vibration and rotation, while UV and visible, they are causing electronic transition along with vibration and rotational transitions. So this is the picture which is shown different radiations which are causing different changes in the molecules. So we are trying to explain the Lambert and Beer, both of them, they try to explain how the intensity of light is changing. So the Lambert has explained the intensity of radiation decrease in intention of decrease in intensity of radiation depends on the size of the solution. So how it is shown is the intensity will decrease as thickness will increase. So further, it has been improved. I will skip this equation. So Beer has made another statement. So he has said, he has given the solution. It is along with thickness. So it is the decrease in intensity depends on the concentration as well as incident light, radiation of the incident light. So here the equation has come up that the absorption which is equal to E into C into L, that is path of the line, path of the cell which we are using, and C is the concentration, and E is the extinction coefficient. So this is the how it is given, Lambert and Beer. So this is instrumentation part I will skip, which is used for detection of the spectra. So here UV is comprising from 10 to 400 nanometer, and while 400 to 800 nanometer, so it is related to visible spectroscopy. So most of the common solvent which we are using, so they are transparent in the UV region. So those solvent only we can use in this in the UV for detecting UV and visible. So electronic transitions, depending on the type of the bonding present. So it may be molecule may contain sigma bond or pi bond, or it may contain some the non-bonding molecules like chromophores, which may contain the unpaired electron which is not participating in bond formation. So of course sigma bond is very strong compared to pi and non-bonding electrons which are participating in excitation of the electrons. So this is various, which is the pi diagram which is given. The highest energy required for the transition of sigma to sigma transition, while the comparative less energy is required, least energy is required n to pi star and pi to pi star. So here n to sigma star. So we will see which the transitions are forbidden and which transitions are allowed. So here the same thing has been shown. So sigma to sigma star is possible for the compound which is containing only single bond, and the compound which contain minimum one or more than one pi bond. So this along with sigma to sigma star, pi to pi star transition is possible. So this is possible. N to sigma star is possible only the molecule which containing uh, the uh, the atom like nitrogen, oxygen, and sulfur. So which are not participating in actual bond formation. And N to pi star. So this is the compound which containing pi bond as well as the another atom or molecule with lone pair of electron. So like carbonyl group or cyanide group or nitro group. Similarly, so these electronic transitions, so it is shown show absorption above 200 nanometer, and so which may be accessible by the UV visible spectrophotometer. So here I have shown, so which transition is possible. So this is the constant factor 0.87 into P into A, where P is the transition probability with values 0 to 1, and A is the target area of absorbing system, that is chromophore. So if it is more than 10,000, so extinction coefficient, if it is more than 10,000, then we can say the transition is allowed. While if it is less than 10,000, so then transition may not be detected and it is forbidden. So these are the terms which we are dealing with the UV and visible spectroscopy. The chromophore group, chrome means color. Any molecule which is the helping to generate color or to impart color to the basic molecule. So that we call it as a color chromophore molecule. So this is helping to enhance the transition, and transition, because transition molecule is visualized by our retina. So here it is given non-conjugated alkene or non-conjugated carbonyl groups. So they are acting as a chromophores. So here some of the examples are given. So hexadiene and 2,4-hexadiene. So here it is found because of the conjugation system. So this first is not conjugated, 1,5-hexadiene, while second is conjugated, which is helping to increase the absorption. Similarly, so another example is given here. I will skip this. Here, the intensity of color which is increased by the molecule. So that is called as a auxochrome. For example, so here benzene is colorless, but phenol is colored, and aniline is also colored compound. So as this phenol OH group and NH2 group, which is helping to participate in conjugation. So that is why, so this type of group which are enhancing intensity of the light, or which are enhancing intensity of the color. So that is called as auxochrome group. So we can give many examples in this auxochrome and chromophore. So here another terms which are used, bathochromic shift and the hypsochromic shift. So bathochromic shift is related to absorption maxima of the compound which shift to the longer wavelength. For example, benzene, as I shown in the previous example. So benzene is colorless, but if we are incorporating the any group which is providing more conjugation, then we call it as a the molecule is shifting towards red shift. That is called as bathochromic shift. And hypsochromic shift, the any molecule or any group, so that will reduce the intensity of light, and it is uh, shifting towards the blue color, or intensity of light will be decreases. So here, so that is called as a hypsochromic. For example, you see here aniline, which is colored. But in acidic medium, so the lone pair of nitrogen on the aniline, so it is engaged, it is donated to H plus, and it is forming anilinium chloride. So you will find here uh, the intensity of the light lambda max has been decreased from 280 to 265. So whereas in red shift, so here it is shown. So in alkaline medium, so conjugation is increases because of the abstraction of the hydrogen here. So red shift is enhancing, while blue shift is reducing the absorption. Similarly, another example has been given with hyperchromic and hypsochromic. So hyperchromic, which is increasing intensity. So when absorption intensity is increased, that is called as hypo. This is like, we are talking about solution, hypotonic and hypotonic. So likewise, hypotonic, if intensity is increasing, for example, in one small room, we are fixing one tube light or one LED light. But if instead of one, if you are fixing two light, so intensity will increase. So likewise, so it is helping the group which is helping to increase intensity. So that is called as hyperchromic. And if it is decreasing the extension coefficient, see here extension coefficient has been decreased. And for example, naphthalene, if it is converted to methyl naphthalene, 2-methyl naphthalene. So extension coefficient absorption intensity is decreased. So that is called as hypochromic shift. So here it is diagrammatically, it has been shown the hypochromic, and the molecule which are showing blue shift and red shift. So another terms which are the helping to which are playing a big role in UV visible. See here it is shown. What is the effect of conjugation? See here naphthalene, and here one more ring has been added, that is anthracene, and one more ring has been added. So here you will find, so intensity of the light is increasing continuously. See the blue color, the spectrum is shown. So it is, you will find, so there are a lot of ups and downs, and whereas here in naphthalene, so there will be very small absorption. So here you will find, as the number of conjugated moieties are increasing, so you will find, so there are, so the intensity of the light which is absorbed in the visible region has been increased. So thus we can say here, increasing conjugation, so it will increase absorption of the light towards higher wavelength. So that we call it as a bathochromic shift with hyperchromic effect. So here I try to show the how pH is affecting on the absorption of the spectrum. So here you see the phenol, if it is treated with alkali, so it will abstract the electron and it will convert to phenoxide ion. So here you will find, see there is a conjugation of this lone pair of electron, and it is forming the quinoide ring. So quinoide ring is helping to increase the conjugation, and this is helping to increase delocalization and leading to formation of conjugated. So this is conjugated system is forming, and it required, in such case this electron excitation required less energy, and thus more absorption band you will find. Similarly, another beautiful example, so here which is repeated in the previous slides, but here it is shown how it is the anilinium in acidic medium. So it is losing the conjugation. But in alkaline medium, so you will find here it is forming a anilinium ion along with formation of the conjugation. So this is decreasing the wavelength of absorption, that is called as hypsochromic with hypochromic effect. So there is another example where this dye, azo dye, so it is giving red color in acidic solution. So because the lone pair of electron here is engaged in acidic medium here. So the lone pair of electron is, so here the lone pair of electron on this nitrogen atom is captured by the hydrogen, and so conjugation which was here, so this conjugation has been increases continuously. So it is helping to form a red color. While here in absence of the H, so it is yellow in color, which is having less intensity. Another beautiful example is the phenolphthalein. Phenolphthalein is pink in alkaline medium, which is more than 9 pH, which is acting as a very good acid-base indicator. So this is the structure of phenolphthalein, so which is obtained by reaction of phthalic anhydride with phenol in presence of concentrated H2SO4, which is acting as a dehydrating agent. And you will find here what is happening when when concentrated the alkaline solution has been increased or alkalinity increases. So there is removal of this, one of the abstraction of the hydrogen atom is taking place, which is forming and breaking of the bond is taking place here, which is forming the acetate ion here, and conjugation is increasing, which is helping to become pink in color. So phenolphthalein, which is colorless in acidic medium, so which is converting to pink color in alkaline medium. So this is how the pH is the helping to playing a role in color formation, or you can say hyperchromic as well as bathochromic shift. Similarly, another example, methyl orange is also showing the color change from red to orange yellow in acidic medium. So this is another important point, basic point. We are using this UV visible spectroscopy technique. There are various applications of this. So we are studying the changes which are taking place when chromophore group is incorporated in molecule, or when oxidation or reduction is taking place. At the same time, we need to study the different pH. What is the effect of pH on intensity. So here it has been shown the change in pH. For example, you see pH 1 and 10 with molecule which are showing different absorption at 1 pH as well as 10 pH. But at the same time, the beauty of this is at different pH, the spectrum will be shifted to different lambda max. So here it is shown. But see, very important second point. But all the spectra at certain wavelength, they are meeting. So here it is meeting. See, here it is shown. So this is isobasic point. So it means what is the role of this? To find out isobasic time when you are studying UV visible or lambda max when you are determining. So we need to study effect of pH, different pH. So that will help us to know maximum absorption at different pH. And at the same time, the isobasic point is helping to decide the pH at which we should calculate the lambda max, and the pH at which we should consider for the experimental purpose. So this point is helping us for the researcher to use the UV visible spectroscopy at particular pH. So thus we can say the lambda max is affected by pH, and which must be buffer at specific pH during during the absorption. So this is very good point. Similarly, colorimetry is also the following the same principle of UV visible spectroscopy. So which needs you will find the complementary color is obtained. The color which is absorbed, you will find the complementary color will be observed. So this is the principle of the chromophore which is present in the molecule. So whatever color is reflected, we can say in other words, so that color is visible to our retina. So likewise here, red substances absorb blue green color and transmitted red light. So likewise, so this table will help us to know which color is reflected and which color is visible to us. Same color which is visible, which is reflected. So what are the requirement? So for example, for colorimetry, which is based on the UV visible, so we need color substance or organic dye or color substance like copper sulfate. And the substance to be analyzed, if it is colorless, it must react with some reagent, that is chromogen. So that it will form a color compound. So that is helping to determine the absorption by using colorimetry. So here I would like to give some few application of UV visible. So it is helping to determine extent of conjugation. We can distinguish conjugated and non-conjugated compound based on the absorption. Similarly, detection of chromophore group. So we can detect chromophore group by using this absorption. Identification of chromophore, then geometric tautomerism, keto-enol tautomerism. We can give qualitative and quantitative analysis of the drug. Similarly, we can give we can find out impurities present in the solvent. Similarly, molecular weight can be determined by using Beer's law. So these are few applications which I mentioned. So I will shift over to infrared spectroscopy. As I mentioned in the previous slides, infrared spectroscopy, IR radiations. So is basically the helping to increase the, it will not break the bond, but it will help to increase the stretching and binding forces. So on the earth, you will find when sunlight is receiving on the earth surface, so you will find these IR radiations are helping to heat the earth surface, these IR radiations. So that is helping. How it is the after interacting with the molecule. So IR radiations which are ranging from 400 to 4000. Out of this, so that we can classify into two regions. One is fingerprint region, that point will come again, and another is functional group region. So here it is mentioned. So less than 1000, so it is called as fingerprint region, where just like our fingerprints never matches with any other person. So likewise, some of the IR spectra of a particular compound are fixed, so they never be repeated by another molecule. And 1000 to 4000, so this is functional group region, so which is helping to detect different functional groups. So this is a very good tool for the researcher to identify, to get basic because see, every district or every state, we don't have, every educational institute we don't have NMR. So likewise, there is a basic instrument IR and UV. At least IR spectroscopy is giving an idea whether our compound has been formed, or where a particular functional group which we are targeting, that is formed or not. For example, you are oxidizing compound, or you are doing reduction, or you are doing esterification. So you will come to know which group was present in my previous compound and which group should be present in the another compound. So that can be detected with the help of this infrared spectroscopy. So this, as I told you, so this IR radiations, when it is absorbed, so it will cause stretching and bending of uh, the molecule of the bond, different bonds present. So this slide is repeated. I will skip this. So here IR radiations depends on the Hooke's law. So the frequency, which is directly proportional to K, that is force constant, and inversely proportional to mu, that is reduced mass. So for example, see here the same formula has been given. The force constant, that is nothing but bond strength. So more the bond strength, or you can say more the value of force constant, so the frequency will increase. It will have more value. So while if it is reduced mass, or see here you will find, so as it is denominator, so the M1 M2 will come at the denominator, and M1 plus M2 will go to the top. So here you will find more the mass, so less will be the frequency. So stronger bond, higher stretching frequency you will get, and larger the mass difference. So here you will find larger the mass difference. If the mass difference is more, then stretching frequency also will be more. Similarly, here you will see some examples are given. So if the mass, see for example, proton, here deuteron is given. So oxygen still mass is more. So chlorine still mass is more. So here you will find the if mass is increases, how frequency is decreasing. Similarly, strength of bond is given. See carbon-carbon single bond. Here carbon nitrogen single bond, carbon nitrogen double bond, and carbon nitrogen triple bond. So here you will find, so carbon nitrogen triple bond is absorbing at higher frequency compared to single bond. So this is helping to know from the Hooke's law how force constant is directly proportional, that is bond strength. And this is another example where you will say, so if molecule is small and the vibration will be more, and iodine is very big molecule, so it is having very more structure, it is difficult to move, so vibration will be less. So even though same type of radiations are absorbed by the molecule with uh, smaller size and bigger size, you will find it, we can see the how it is influencing on the mass. Similarly, here another example I have given, single carbon single bond, carbon double bond, and carbon triple bond. So here as the strength of the bond is increasing, so here frequency also will increase, bond as because bond strength is increasing. Similarly, CH bond, here you will find, so this is carbon single bond, here carbon double bond, and here carbon triple bond. So as you know, this is sp3ch, this is sp2ch, and this is spch. So in other words, I can say percentage of sulfur, percentage of S character is more here, is 50%. So here it is, sp2 33%, and here it is 25% only. So as S character is increasing, so frequency also is increasing. See how it is from 29, it is highest in C triple bond C, but it is a bond of the C and H, not C and triple bond. I'm talking about C and H. So that's for heavier atoms, same example is given, C carbon H Cl I. So here how it is decreasing. So this will help to prove again the Hooke's law. So there is another example how vibration of the atomic molecule is is taking place when higher radiations are absorbing molecule. And after absorption, so there are different stretching oscillations, or it's a bending. So either bond will stretch or they will bend. So there are two types of stretching, maybe symmetric stretching, which is shown here. So it is same time, both the bonds are moving away and again coming closer. So here it is asymmetric stretching. So asymmetric stretching will have the more absorption compared to symmetric stretching. Here it is shown the scissoring, just like scissor, we are cutting paper with the help of scissor. This is rocking. And here it is out of plane. You will get more clear idea here. See symmetric stretching here, asymmetric stretching, here wagging, this is twisting, and this is scissoring, and this is rocking. Another, the pictorial two-dimensional picture I wanted to show. So this is symmetric stretching and this is asymmetric stretching. So here both either they will go away from each other or they will come closer. So this is symmetric and this is asymmetric. Similarly, this is in plane. So they will not move the plane. They will remain, all the atom will remain in the plane only. But here if it is moving, so it will go, see next one, it is shown out of, so both are going out of plane because they are going in the opposite direction. So this is also out of plane. So here, when these vibrations are taking place, so it will generate the frequency that can be detected with the help of the infrared spectrophotometer. So here, when the electromagnetic oscillating waves, so they are incident on the molecule. So there is oscillating. This oscillating molecule is caused because either by stretching or bending, so which will form the waves. So that can be detected with the help of IR spectrophotometer. So this I will skip because we want to discuss about some more applications. So here just I will go through the block diagram of IR spectrophotometer, how it is the helping to get the record. So this is instrumental part I will skip. And another figure, see how it is moving from the light source. So this light source is coming to the through this mirror. So this is movable mirror and this is fixed mirror. And so here is a sample uh, which is absorbing, and we are getting the the spectrum which is detected with the help of detector. So here like this. So sorry, sample chamber is here, which is producing uh, the IR radiations, which is creating IR vibrations, and which is detected by the detector. So here, so main function of this, it is helping to detect functional, which I told 1000 to 4000 per centimeter. That is helping to detect the functional group. Every functional group is having some typical absorption capacity. So we can get some idea about the organic acids, or you can say maybe liquid or gas sample with the help of functional group are present. So maybe, so there are improved instruments have come up now. So we need not prepare PBR plate now. Directly we can sprinkle even liquid solution or solid solution, solid sample. So it will give quickly within for 2 or 3 minutes you will get IR spectra. So here there are various applications in pharmaceutical, forensic investigations, polymer analysis, lubricant formulation, food research, environmental, biomedical. There are many applications. So there are many advantages, except the bottom I have mentioned. So it is having main disadvantage that it's sensitive towards CO2 and water which is present in the atmosphere. So that is why we are getting sometimes the very big, broad peak with the help of, if the sample is containing moisture, or if your sample is hygroscopic in nature. And CO2, it is available everywhere. So if we are trying to avoid this, moisture we can avoid by using dehydrating agent, which will absorb the moisture. And CO2 can also be avoided. The instrument chamber can make free from CO2. So here we can say the many advantages: better sensitivity, high wave number accuracy, resolution, and then wave number range flexibility. So all these advantages we can take. How we can distinguish one molecule from the other molecule. For example, you are doing any reaction, you are changing one group to other group, acid to ester, or you are reducing, you are reducing, suppose, alkyne to alkene. or if you are reducing a nitro group to amino group, so that can be detected with the help of this. So here there are 5 regions which are helping the chemist and researcher, we can say. We cannot, because this is not the property of chemist. So anyone can use. There are 5 reasons which are shown here. So reason one, so which is if any researcher, if you remember this 5, if you mug up this, or if you write 4 5 times, it is helpful for us to remember which group is present, which group was present in my sample, and which are the expected group. So here you will find, you can identify very easily first zone. So 32 to 37. So OH group of the alcoholic OH group, and the amido group or amine group NH2. So this is helping to get in the first region. Similarly, so this SP, as I told you, this is SPCH, which is also coming here. But of course, this is a broad and this is sharp. So that I will show you in the next slide. Similarly, zone second, which is 27 to 32. See here, 32 is common here. So you can just remember here also 500 difference is there. Here also 500 difference is there. So this zone 2, here it is SPCH, here sp2ch and sp3ch. Of course, so this sp2ch may be aryl, or you can say benzyl or vinyl. So both are having sp2ch. So which is having more frequency, which is variable. And then next one is sp3ch. So this is just, it is coming very nice next to below 2000. So you will know, if you see some 10 15 spectra, so you will come to know how beautiful it is. The only thing, your IR spectra, before taking IR spectra, your compound should be crystallized 2 times. Or if you are recrystallizing or purifying 3 times, you will get such a nice spectra. You will enjoy the spectra and you will feel happy. Yes, my compound is very pure. So you will enjoy, only your compound should be pure. Then aldehydic CH, of course, it is CH. This is also CH. Aldehydic CH, of course, that carbon which is attached, that is sp2. And here it is showing there are 2 bands. Here 27 and 29. Of course, it will vary. It may come to 2710 or 2720. Here also it will come 10 20 difference will be there. So here 2 bands are observed, because this H, which is forming the overtone with the CO bond of the aldehyde. So that is also called as Fermi resonance. And carboxylic group OH, here also OH. So this is again 25 to 3000. So this is zone second. Of course, uh, for the beginner, or even if you are completing your PG, or even if you are completing your research, so being a teacher, I am always a student. So likewise, teacher cannot say that now it is enough. So we need to study continuously, and we need to encourage students how to remember, because some points you have to remember, just like our primary teacher is mugging up, asking to mug up, tables, or alphabets. So even if we are becoming very very old, still we will remember the same methodology which is taught by our teacher. So it is a great man, as you can say, a man or woman, you can say, who are participating. We are giving services, noble services as a teacher. So we can encourage students to remember this zone. So this is third zone, that is 2002 to 2300. So alkyne and nitrile. So this is giving again. So these are very near. And the next one is ketone. All ketone I have not mentioned here. Actually, first should be up to 1850, which is mentioned here, 1650, 1850. And next one, it is shown, see, 1450. Here you can remember 1650. So here I want to show here. So all ketone. So here I have not mentioned, anhydride CO. Anhydride CO is showing above 1800. And another is COCl, that is acid chloride or acid bromide. So that is also showing above this. Then ketone is coming, see, the aldehyde is coming, amide is coming. So then you remember like this. See, aldehyde ketone we know, then you acid and ester. So you remember like this series. So if you remember like this, amide, which is having the least frequency. And here I have not shown, as I told you. So anhydride will be having the highest frequency, above 1800. Above 1800. So this point will come only if your compound is having more than one type of carbonyl group. Otherwise, So this range is enough for you. So this will help you to determine the type of the group present. For example, acid group, if you are converting to ester, so you will come to know, so it is in between this 35 to 1735 to 1750. Of course, this is not exact value, so it may vary. Similarly, at the bottom, you see here it is given. If your carbonyl group is in conjugation, so it will lower the frequency from 20 to 40 per centimeter. And last, which I mentioned here, that is carbon and carbon nitrogen bond, and here the benzene ring again 1450 to 1650, you can remember. And here again I did not mention here uh, carbon oxygen bond. Carbon, that is that we can call it as, for example, COO group is there. So C single bond O, that also comes under 1600. So here, sorry, here it is mentioned. So here we'll find, so this CO, that is sp2CO, which is connected to carboxyl group. Similarly, carbon carbon and carbon nitrogen. So this is also showing around 1200. Then so here we know this, some bonds are very strong, some bonds are medium, and some bonds are weak. Of course, IR spectroscopy is not giving exact structure. But we can get an idea that yes, whether my reaction has taken place or my compound has been formed. Maybe impurity. That is why I'm saying if you go for at least for spectral analysis, we can go for minimum 2 times, crystallization. Or if it is not possible crystallization in case of heterogeneous catalyst, you wash it with the some solvent 2 times, 4 times, so that your initial compound which are present reactant, so it should be removed completely. So here I try to explain with the help of the how intensity of the band will increase. So it depends on the dipole moment. So dipole moment is nothing but it is the product of bond length and the dipole which is created because of the two atoms. So here we'll find. So if it is bond dipole is increasing, then bond length will increase, dipole also will increase. So bond dipole will increase, absorption also will increase. So likewise, you will get very strong peak, that is symmetrical, maybe non-polar and nearly symmetrical. So if it is nearly symmetrical, then it will be peak. It will be very weak or it will be absent. So these are the four the bands which are shown here. Say fingerprint region. So it is very difficult to detect, but it will give an idea if it is your compound is for example ortho substituted in case of aromatic, or meta substituted, or it may be para substituted. That will give an idea. That is why it is called as fingerprint region, which is not repeated by any other molecule. So this is the first region where we are shown this is above 3000 200 to 3700, and this is carbon carbon triple bond double bond. This is 2000 to 2300, and this is the 1680 to 1850. And so this is fingerprint region. So this here it is shown double bond, triple bond, single bond. Here we'll find some of the how the frequency will change depending on the, this is repeated actually. And another point, this point which is shown here, if it is conjugated, then it will reduce. See, it is reduced from 1640 to 1680. It has been reduced 20 to 40. And the aromatic carbon-carbon bond, it is coming around 1600. Similarly, carbon, as I explained to you, so if it is S character, if it is increasing, for example, you see here, if S character increases, so here sp3, sp2 and sp, so frequency will increase and it will absorb with higher frequency. Here, as I told you, if the aromatic compound which is containing monosubstituted, so it will give the typical absorption, while it is ortho, para, and meta. So this is ortho, para, and meta. So you can remember it. See, with the help of this, see PMO, we know Prime Minister Office, PMO. So P stand for para. So this para is giving highest if it is two compounds, two substituent present, then meta substituted, next one, and then ortho substituted. And mono substituted will be in between 690 and 730. So this is the common frequency. Of course, everything you need not mug up, but the 5 region which I told, you keep it on the table, and always while searching, before you checking your spectra, you just keep all the spectral data in front of you. So automatically all the approximate figure you can remember, and it will help to determine structure of the compound. For example, see here the octane, which is having only uh, sigma bond. So here you will find, so weak to strong bond is obtained here. It is of course less than 3000. Aliphatic always shows less than 3000, and aromatic it will show above 3000. So likewise here you will find, so this is carbon carbon single bond as it is shown here, cs2 cs2 and cs2 cs3. So as there is no functional group, only carbon and hydrogen. Similarly, here if it is alkene group is present. So alkene group. So if you see here there is no carbon-carbon double bond which is coming in between 1650 to 1800. Sorry, 1450, 1650, which is coming here. So this is a typical bond which is coming. At the same time, here you will not find anything here overtone, because it is aliphatic in nature. So you will come to know. So this, when it is compound is aromatic, you will find some overtone here. So all are sp3 here. These are sp2. So sp2 is coming here. Now alkyne, of course this is unsymmetrical alkyne which is present at a terminal alkyne. So this CH will come, see sp3. See, this is a very strong peak which is available here. So this is helping us. And at the same time, you will find this bond is not present in carbon-carbon double bond. See here, but carbon-carbon triple bond is present here. So it is present around 200, 2100 to 2200. So here this is very strong. And again, these bonds are common, which are sp3c and sp3h. Similarly, you see now here, as I told you, so you will not find any overtone here, no overtone here. But you see the moment you are taking example of ethyl benzene. So here there are carbon-carbon bond which is available here, aromatic, because aromatic there are two, carbon-carbon and carbon, alkene and aromatic. So aromatic will be lower than aliphatic. And at the same time, you will find here the carbon sp2h. So sp2h here you will find, see now here above 3000 is coming here. See here, this is not visible to you bottom, but it is written here above 3000 to 3100. Okay, so this will not confuse with your NH or NH2 or your OH group. It will not confuse 100%. So it will always above 3000 and below 3100. It is in between here. And here you will find, so the next to this less than 3000 you will find this peak. And see here this green color which is shown, so this is overtone. So this overtone is obtained because of the combination band. It is also called as combination band, which are due to presence of the benzene ring. And this is the carbon-carbon bond of the carbon-carbon double bond of the benzene ring. Similarly, you see ether. Ether also, see, you will not find here any overtone band here, but carbon-oxygen band is present, which is around 1200. Maybe written here, see 1150 is written here. So this asymmetric stretching and vinyl, which is not present here. Vinyl group is not present here. So here we will find, of course, this is less than 3000. This one is less than 3000, and this CO bond is available around 1200. I'm always telling, so whatever figure I mentioned, 5 groups I mentioned, that may not be exactly, but it will give an idea. So of course, so the CO bond, that is called as fingerprint region. Now OH group, so here broad band you will find here, OH group, because of the OH. So now here 34 to 35 it is C, 32 to 34. And CO bond which is found here, CO which is available here. And of course this will be less than 3000. See here, 3000 is visible here. So this will be less than 3000. So this is CH, which is aliphatic, and aromatic if it is there, it will be above 3000. Similarly, NH2 group, this is the beauty. Primary amine, secondary amine, and tertiary amine can be identified by using this. So you will find 2 humps here, 2 humps, NH2. So these 2 humps, because of the, it will indicate just like 2 NH2, 2 hydrogen atom, it will give 2 peaks. one hydrogen atom, it will be one peak. So likewise, so it is of course around 30, 35 or 3400. So which sometimes which is maybe merge with the moisture peak. That is why our sample should be moisture free. And as there is no aromatic region here, so here also you will not find any hump. And at the same time here this is less than 3000. So that is why I'm saying if your sample is very, very pure, so you will get beautiful spectra, which is available, spectroscopy, spectrometer is available in Nagpur. Of course, I don't know about Amravati, but Nagpur, it is very near, it is available in Institute of Science. So these are the another bond, CN bond, which is available, which is weak in nature. Now this is secondary amine, which is shown here, say only one. So here you will find there are two peaks, but here you will find only one peak. Again, it is 32 to 35, and again less than. So this is aliphatic, of course, uh, uh, this is cyclic compound, but still it is showing aliphatic in nature. Similarly, you will find the OH group, which is present, which is having the broad peak in from 2800 to 3000. Broad peak you will get, and NH2 R2NH. So you will get this is very faint in color. I'm very sorry for that. And NH2 you will get doublet, double peak. While tertiary amine you will not get anything. So here you will find the difference. OH is broad, but at the same time, which is in the same region. If you see the C triple bond C, that is SPH. So here you will get sharp peak. This is the difference between the two. Both are present in your compound. Then you can identify this is a broad peak and this is a sharp peak. Of course, so this can also be sharp if your alcoholic group is not containing hydrogen bonding. Then you will get this type of structure. But of course, there will be a difference. We can identify very easily. And see here, as I told you, so this is shouldering, or I told you that is overtone, which is always obtained because of the P. So this overtone is obtained around this, and the aromatic CH above 3 and 3000 and less than 3000, there will be aliphatic one. So here another compound which do not contain aromatic, aldehyde group. So here you will find there are two peaks here. Say the 2720 and 2820. So because this is called as Fermi doublet. So it is called as Fermi resonance also. And this is OH, sorry, CO group. The CO group which is available here, and this is Fermi doublet. Aldehyde group means 100% there will be doublet. So you can identify whether my compound is containing aldehyde group or which is oxidized. So this will helpful. Similarly, another aliphatic aldehyde, butyraldehyde, which is shown. See here, Fermi doublet is shown. Then CH, CH saturated CH, and here you will find CHO stretch. So this one, and carbonyl group which is available here. Similarly, ketone also you will find here the same CO group, and it is less than 3000, less than 3000. Now here tertiary group, and this is ester group. Of course, ester group is above, so this CO group which is present again here, and you will find the red color CO bond, so which is coming around 1200. So this comes under fingerprint region, and less than 3000. So again aliphatic CH. Similarly, so this OH group, see this is a very broad peak. Normally, sometimes if it is acetic acid, you will get dimer, or if it is monocarboxylic acid, so you will get this type of structure. So here yellow color which is shown, so this will be the CO, and you will find here. So this is overtone, and aldehyde. So which is this is OH, COH. COH is also found here, and in between 2400 to 3500. So here you will find here the COH band as well as OH band as well as CO band here, red color, and CO which is obtained which is shown in the yellow color. Similarly, as I told you, if it is dimer in state, you will get very broad peak. Same structure here. Then you will find anhydride, which I told you. So which is coming. See here, it is shown above 1800. Anhydride is always coming at the top. So 1800 to 1840, and so this another band which is obtained because it is containing two CO group, and less than 3500, and this red color, that is CO color, red color which is shown, that is C single bond O. Similarly, COCl, as I told you, COCl next to anhydride is coming, it is 1800. See, it may be given here. Yes, it is given here. So up to highest is as anhydride, then COCl is coming. Similarly, NH2 group, see the beauty of this. So you will find two peak here, with identification, and CO group, which is in combination. Amide is coming at the lowest, so it is less than 17. See here, 1640, 1680. So this is the lowest in all carbonyl group, amide. Similarly, nitro group also you will find. So you will not find any overtone band here. Only CH is stretching here, and you will find here the single bond, N single bond and N double bond. Similarly, triple bond, C triple bond. So this is the second band group. So which is coming here around 2200. Yes, 2000 to 2300. So it is shown 2280. And again, so below 3000, you will find around 22900. So this single bond carbon single bond. Similarly, as I told you, if the alcohol, see here, you will not find any difference. So this is 2-butanol and this is isopropanol. So almost same type of spectra you will get. So this is the drawback of this IR. You will come to know OH group is present, but you will not be able to identify. There is no much difference in the spectra of butanol and isopropanol. But you will get an idea whether the compound is pure and compound is having hydrogen bonding or not. So here a broad signal you will get if it is hydrogen bonded, and if it is not hydrogen bonded, so then you will get sharp peak. So it means if solution is dilute, so here it is shown how hydrogen bonding is forming, and hydrogen bonding is helping to weaken the bond. So that is why stretching frequency it will reduce, and you will get broad band. So here this compound, the sample is containing both OH bond, which is free from hydrogen bonding, and which with hydrogen bonding. So here sharp peak is also obtained and hydrogen bonding is also obtained. So this is shown example that how we can say the compound is containing hydrogen bonding or not. So with this, so I will come to the end of this. So the great man, the Ratan Tata, so he has given very good quote. If you want to walk fast, so you can walk alone. But if you want to walk far, very far, then you have to walk together. It means we need to work together. Then only we can progress. This is the quote which is given by a great man. And this is a beautiful girl who is giving greeting to you, all of you, those who are very patient listening. I just shared some of the experiences, and I'm working with this beautiful institute, VIT, having 4 branches. So we got the ranking TI, national ranking framework. We are at 15th position. So because see here it is shown. So we are at 15th position because of there are very many factors. We are having very good global MOU. We are having all types of programs, the BTech, MTech, BSc, MSc, BCA, all types of programs we are having. Similarly, our students are having academic freedom, which are growing, which are helping to grow all-round development. We are having more than 2,000. I did not correct it. More than 2,000 faculties, and supporting faculties 3,500. So almost in our campus now, because of the lockdown, we don't have any student, but our all programs are running online with Microsoft Team, and we declared the result and started second session. MTech admissions are MTech MSc admission are full, and they will be with us from 27 of this month. And BTech admission also we are going ahead. So we are having whatever data I am giving. This is all real data. Dr. Prashant has experience. He was very good student of my group. He inculcated very good habits to my group, even though he was a faculty. But I appreciate his dedication and his hard work. He generated, such a beautiful ideas in my lab, so that all the ideas, they are coming true. and he has developed the some good habits to the student, that how we have to clean. Even though he was a professor, he came on FIP, Faculty Improvement Program, and 3 years he lived along with all my research scholar. Of course, I am living along with my students as a family member. I never treat them as a student. I'm always treating all the students, my research student particularly, because next to parent, only guide knows what student is. So we have beautiful hostels, girls hostel, boys hostels. This is old data. Again, 3 more hostels are coming up that are not added. Again, two girls hostels, they are coming up. They will be ready. Everything is going on. Construction is going on in the campus. Now we are having 10 research centers, big campus amenities that will help to develop overall personality of the students. And this is 24 hours we are working. We never come to home before 8:30. That is always complaint from my wife. And we are having 10 dedicated teams. Our students are also working. We are having very good platform for research. Of course, academic is the first. Research we are giving. We are coupling research with the academics. And this is the last year data where students have achieved a lot of laurels in placement. And this is old data, actually May, latest data I could not added, but here you will find VAT how it is, it is ahead. Even IIT, all IITs in number of papers, and we are trying to increase our paper quality too. So quality also we are trying to improve. That is why our edge index has been increased from 35 when I joined 2009. Now it is more than 115 H index. So here you will find uh, the next is SAS, means School of Advanced Science. So we are having different schools, so which are contributing number of papers. So our school is always ahead. In my chemistry, we are 77 faculties, chemistry faculty 77, and maybe highest in India, you can say. I don't know whether how many chemistry faculties are there in ISC, but among the private, we are top. And School of Advanced Sciences formed by physics, chemistry, and mathematics. So overall, we are having 255 faculties, and so we are contributing for the research. As I told you, H index I have not updated here, but it is cumulative impact is 371, and see citation index is 5.91. Similarly, chemistry department has achieved very good rank. So last year it was 15 rank overall world rank, and now it has improved to 14. So previously we were in 500 to 550. Now we are 450 to 500. So this is because we are again additional, one more laurel in our cap. Announces VAD has announces one of the 10 IOU, Institute of Eminence. Recently, Monday and Tuesday, there was a meeting, online meeting with to confirm the status, IOU status. We were having a meeting, and we hope that VAT will be successful to maintain the status. And it is all happened because we are competing research, teaching, employability, and internationalization. So these are the points. As I say, VAT is a place to learn. Really, it is chance to grow. As after my joining, I was not knowing what is impact factor, frankly speaking, because I also grown in the same environment in Amravati University, where we are having very few facilities, but we need to develop. Every institute has to promote, every principal, every organizer of the educational institute has to promote minimum simple instruments like UV visible IR. You will get around 10 lakh 15 lakh rupees, nothing. 10 lakh 15 lakh is nothing. VAT is also giving 100% payment to us. In last March, April, May, June, they have not deducted even salary of single person. Even research scholar also, they are at home, but they are getting salary. If VAT can do, why others cannot do? So we are every educational institute should think we are not for earning money. At the same time, we should provide some facility. We should give something to society. So that is very important. You take the example, I see MIT, Massachusetts Institute of Technology, private. which is in America. See the top always in top, first and second rank always. So likewise, there are many institutions those who are dedicating. You see the example of North Korea, sorry, South Korea. So there are many industries. Those are contributing. They are giving, donating to universities. For example, Amravati University, some great industrialist will come, and he will say, "Okay, I am giving some funding to you. You just build up, come up with one center." And that center they will have some MOU, and that MOU, whatever research will come out, so 50% credit will go to industry, 50% credit will go to university. Like that, they are high in MOU. You will find a lot of universities, like LG or Samsung. You will find in South Korea, many industries they have donated and they created such a center. So, unfortunately, in India, we don't have any person like big industrialist. We are not a politician to name anybody, but it is a duty of the person, because they are getting land free from the government, just lease 1 rupee, 1 rupee per year they are paying for 30 years, 50 years. What you are contributing to society, that is very important. So it is required nowadays, because as our prime minister has said, this is the time to grow, to take a chance to grow, to become self-reliance. So this is very important. Everyone, including teacher, I am saying teacher is playing a main role. We should not think about all these things. So what is the secret? I am saying we are having all instruments. I was the in charge were here. These two instrument NMR, I have settled, even though I was not doing anything. NMR and another instrument, that is GCMS, which is shown on next page. Powder XRD, we are having two transmission electron microscope. So this instrument you will find, we were getting previously tea coffee coupon, including research scholar. But our one of the last time our VC has requested everybody that we will stop your tea coffee and we accumulate the fund. So I'm requesting, see the beauty of this transmission electron microscope. We purchased 5 years before, cost is 6.5 crore. See how much money is generated from the tea coffee, because we are having 5,000 people, more than 5,000 people in the campus. Our management used to give us, coupon tea and coffee. So they have stopped and accumulated amount. Had there been any other, institutional person, by seeing this money, he would have utilized for other purpose. But see, our management, I want to appreciate my management, that they have utilized. They are now also they are giving us. Suppose I am asking something, I don't have this much, I don't have fund, I want something, so they are giving money to us. So this transmission electron microscope is purchased from the tea coffee money. Many every year now, single crystal XRD also we got, HRMS also we got. So all instrument except HRMS and single crystal we were not having, that also we got this time. And see the beauty of the outcome, you will find chemistry is always contributing more. Everywhere you go, everywhere in world you go, chemistry people will always have more contribution compared to other department. Of course, in terms of project, in terms of paper, or in terms of other one also, you will find here chemistry is always having better. So these are the different areas where we are working. Of course, another beauty of EAT, we are working on interdisciplinary concept. Chemistry person can do his research with physics person. Even many electronic students, they are working with our chemistry people. This is the beauty. And in our university, if somebody goes, some person goes and say, I want to work with physics, so they will say, have you gone mad? So this concept need to inculcate in our area also. It need to approve in the senate of the every university, that it is needed now to collaborate with all type of people. Then only we can grow. So this is some of the beauty. So this is the last person, Kamlesh, who has graduated, and this is the Professor Prashant, who got degree before that. So now he's the organizer, convener of this function. And this fellow Avinash, these all my students are from remote area. So he is from Yodmal district. Now the moment before he completed a PhD, he got job in Zydus Cadila. And this is some of my this person, he was in company working internal part time. This is a group, and this is my current team of the 6 member. This fellow is from Jarud, Amravati. This fellow is from Jalgaon, Buldana district. He is from Amravati, Subodh. He is from Kolhapur, and he is also from Kolhapur. And this girl is also from Kati, Varud district. So all 6 member beauty you will find all are from Maharashtra. I am trying to maintain because everyone is giving chance to their students. So I am also dedicated. I am always saying that I will give first preference to my Maharashtra students. So even though they are commenting, but I don't agree with that. I'm telling yes, my student also should get some chance. So he is my best friend. We joined 2010 together, but now he left to Germany. He became very big man in Lebanese Institute of Catalysis. You just click it Google, so you will find he generated more than 10 paper in science, and he is his friend. He's scientist in the Dehradun, IIP Dehradun, and these people we all are my team only. All 6 member are here to welcome these two guests. We conducted one conference January 6 to 8 when Nobel laureate Robert Grubbs showered here, and this is my group. You will find Prashant has worked in this lab. He inculcated very good habit to my students. And last year I got one APJ Abdul Kalam Award because of one of my project has been selected to national level. So I work with a chemical engineering student, and that boy also got scientist award, GD Naidu scientist award, and mentor has got APJ Abdul Kalam, my beloved scientist. And this is some of the glimpse of our conference. And 4 years before, our chancellor has celebrated, or we have celebrated chancellor's 80th birthday. And he is a man behind all these things. He is a god in South India. And you will find, so we got chance when his birthday has been celebrated. So you will find more than, more than 15,000 people since morning to evening. They invited everybody, and continuously there was program, and everybody they invited for lunch and dinner combinedly. So likewise, he is a man who attend office. Now he is 84 years. Now also he is coming to office. Of course, in lockdown he is not coming, but he is inspiration to all of us, and he is working very hard. So finally I can say thanks to all for your patient hearing, and special thanks to Prashant and Bhade madam and principal who has given me opportunity to interact with you. So I welcome if you have any question. It
Yes, sir,
is
yes.
an over to Prashant.
Yes, sir. Yes, sir. Thank you, sir, for a very nice talk on UV visible IR spectroscopy. We have given a lot of examples regarding this, in particular in IR spectroscopy, which explain the how to characterize the compound, how to get the idea of which type of functional groups are there in fingerprint region as well as functional group region. So some of the queries are there, sir. So I will read out the questions.
Yes, sir.
Hello.
Yes, please.
So Syed Ibrahim was there. He is asking that I request you to explain the blue shift and red shift.
Okay, blue shift and red shift is just like you can see the example. If you take the example of benzene, benzene is transparent, but if benzene is incorporated with nitro group, so it will become yellow.
Yes.
And if you go for another nitration, it will give metadinitrobenzene, so it is again intense yellow. So it means we are moving towards the red color, higher wavelength. So that is red shift. And blue shift, suppose conjugated compound. Suppose you see the example, another example, natural example I can give. For example, green color tomatoes. Green color tomatoes are converting to red color. See nature's phenomena. See how nature is helping us. So it is just ethene which is present, in the in between. So inherently ethene which is developed by the fruit or by the vegetable. So that is oxidizing the compound and converting to lycopene. So because it contains both the green tomato which is containing more chlorophyll, and when it is ripening, so that is dominating and converting to red color. So
Yes,
this is red shift, and when we are reducing this compound, suppose nitro group we are reducing to amino group, so it will shift to lower valence. So that is red and blue shift.
sure, sir. Nice. Next question is from Krishna Power. What is the difference between spectroscopy and microscopy? Yeah.
Spectroscopy, as I told you, it is giving an idea about the interaction of light with the matter, or you can say various molecule, and depending on the type of the radiation which is incident on the surface. For example, IR is helping to for vibration. UV visible is exciting the electron, or NMR nuclear shift is taking place because of the radio frequency. So likewise, this is what when there is interaction of light with the molecule. So that we call it as a spectroscopy. Spectro means it is coming in contact with there is interaction of this light with the different bonding. And microscopy, which is visualize, which is increasing the broadness of the visual, which is visualizing, expanding the figure. That is microscopy.
Okay, sir. Thank you, sir. Next question from Omkar Kapse. How do different solvent impact the absorption spectra of solvent molecule?
Can you repeat the question?
How to
Yes, please.
differentiate either the solvent impact on the absorption spectrum of the solvent molecule, like that. So I think something question
it depends on the solvent which we are using. Of course, for example, benzene, suppose toluene we are using, or we are using acetonitrile, which is not absorbing any UV or visible light. If we change the solvent, so sometimes because solvent, there are polar and non-polar solvent. So if there is formation of if it is polar, it is disturbing the bonding, or if it is polarizing bond, we know there is a impact on electronegativity, or there is impact on hydrogen bonding. If it is forming hydrogen bonding, it should not change any structural, or it should not disturb any bonding from the molecule. That solvent, definitely it will influence on the spectral data.
Next question: which electron excite easily, N, pi, or sigma?
Of course, it is non-bonding electron will excite, but it may not be, as I told you, it may be forbidden. And next to pi bond, and next to sigma to sigma, it requiring lot of energy. So pi bond, N to pi it requires very least energy, but it may not be detected. It will be forbidden sometimes.
Okay, sir. Next question from Chandrakant Nandre. How will you detect hydrogen bonding by IR spectroscopy?
It is very good question. Hydrogen bonding, you will come to know if hydrogen bonding is not present, then you will get a you will get a sharp peak. In one of the spectra I have shown, so there are both the types, broad band as well as sharp band is present. If it is sharp band, it means 100% there is no hydrogen bonding. For example, if you are taking IR, you are reading IR with the help of the non-aqueous, or again the non-polar solvent. So you will find there is no hydrogen bonding. It means molecule which are present. For example, if you add water and alcohol, it is miscible 100% because they are forming intermolecular hydrogen bonding. But if you take non-aqueous solvent which is not interfering, so then that alcoholic group, it will give very sharp peak. I hope I answered the
next question is from
yes, please.
Next question from Sopan Adau, sir. So, sir, for aldehyde, what could be the reason that gives two peaks?
Because it is called as Fermi resonance, which is invented by the chemist Fermi. So it is interacting with the C double bond O and C. There are two types of group which are present interfering. So CH, which is bonded to sp2 sp2H, and which is also just like in benzene you will get hypotone. So that is why you will get double peak here, or you can say doublet, because of the resonance of this CH with CO. That is why it is called as Fermi resonance, or it is also called as Fermi doublet.
Okay, next question, Shiv Govind Prasad is going to ask. I'm going to enable him to speak. Govind Prasad, can you speak?
Hello.
Yes, please.
Hello.
Yes, sir.
Are you
Yes, sir.
listening?
Welcome, sir.
Yes.
My question is in 2-amino 5-nitrothiazole, I am getting 2 lambda, one highest lambda that is 386 nanometer, but I am also getting some lower peak, but there should be one peak. The question is why we are getting 2 peaks. The only question is that.
In NH2,
2-amino 5-nitrothiazole compound,
yes, sir.
we
Yes,
are
sir.
getting 2 lambda.
Yes, sir.
So one lambda max is 386 nanometer. That is also reported in paper. But another lambda that is come to the lower value. So I don't know why 2 lambda is appearing in the same graph.
Sir,
So
you are talking
we-
about two NH2 peaks, or you are talking about 2 lambda?
No,
2
I'm
maximum.
talking about 2 lambda value. Why 2 lambda exist?
So I think, as I told you, it may be sometimes if the sample is not pure, sometimes it may show.
No, some sample is pure. I'm confirmed.
But if sample is not pure, it may happen. But if 2 lambda peaks, it may be because of, as I told you, maybe some pH difference. As I told you, isophysic point, which is showing sometimes 2 lambda max. So that case, we need to decide the pH at which it will give.
Should I say a picture?
No issues, sir. Because isobasic point is, I think you can take care. You can search about isobasic point. You see lambda max again in the by changing pH.
Okay,
And
sir.
what is the difference, with different pH in lambda max? Then you will come to know at which pH you are getting which pH you are getting isobatic point, and then that you can select while determining lambda max.
Okay, sir. Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir. Very nice talk on the UV-Vis IR spectroscopy. Now I'm going to hand over the session over the vote of thanks. So Dr. Bhade Madam will come.
Very good afternoon to one and all. The best and the beautiful things in the world cannot be seen or even touched. They must be felt by heart. Thank you is one such prayer among them. I, Dr. Madhuri Bhade, is honored to take great privilege to propose a vote of thanks to all the dignitaries who have witnessed this workshop as a memorable and successful event. Today, my words are not enough to express the gratitude. On behalf of Amolak Chand Mahavidyalaya, I would like to thank Honorable Chief Guest, today's speaker, respected Professor Bhagat Sir, for his very interesting, knowledgeable and interactive session, who spared time from his busiest schedule to grace the occasion. Thank you very much, sir. We would again like to hear you on some another occasion. I must express my sincere gratitude toward respected Principal Dr. Mishra sir for presiding over today's function and for his constant motivation and kind support all the time. Thank you very much, sir. My special thanks to all the respected dignitaries and participants for their overwhelming response and interest in this workshop. Your presence graced the occasion. Once again, thank you all for your participation. Thank you very much. I am also thankful to respected Dr. Chauhan sir, Head Department of Chemistry, all the teaching and non-teaching staff members of Chemistry Department for their support that makes the event a grand success. Thank you. Thank you very much to one and all.
Okay, madam. Thank you.
Thank you,
sir.
sir.
Thank you.
Thank you very much, sir.
Thank you, Prajan. Thanks.
WhatsApp group. So you have to fill the feedback.
Thank you.
Okay, Prajan. Bye.
Hello, sir.